I am here to present on the throttling and blocking bad request subject. We just had a very excellent introduction, so I won't repeat it. I'll just get right into the presentation. So yeah, my background is in software security. I'm professionally interested in bot detection, Elixir security, and infosec related to web applications. Prexial.io as a company is focused on bot detection and prevention. So to begin the presentation, I want to note that this is based on a blog post called Throttle Requests in the URL you can see there. If you want to follow along during the presentation, you can go on the Prexial.io website, and all of this code is available. You can go onto the GitHub page or onto the you go onto the GitHub page and get either the credential stuffing script, which is called Envy, and then the victim Phoenix application that we'll be using today is called orru. It's based on a type of crow, if you're curious. People usually have this at the end of their presentation. I just wanted to put it at the start so people can follow along and have it locally. So I'll give everyone a second if you're interested in doing that, and then we'll get started with the main talk.
The audio is great right now, so we can hear you very well.
Awesome. So yeah, let's proceed to the main talk. I want to introduce what credential stuffing is. You may have heard this term before. If you haven't, that's okay. I'll go through an example right now. So it's very common for people on the internet to have a username and password pair for a variety of websites. So for our example today, we're going to have this user, myname91, and he has accounts on Golf Supplies Online, genericbank.com, and a social media website. And he reuses this exact same username and password pair across all three of these websites. What happens next is Golf Supplies Online suffers a data breach, and now any username and password pair that was being used by them is public information, and anyone on the internet can really view it. So now we switch to our black hat. This is the attacker point of view, and he has just collected the Golf Supplies Online breach, and we can see, there's two users, and then our user that we are just talking about is the third one here. And he writes a script to do automated login attempts against genericbank.com. The Golf Supplies Online breach is very big. There's hundreds and thousands of username and password pairs, so it's not feasible to manually do these. So our attacker here has written a script that does these login attacks programmatically. And as you can see, for the first attempt here, the login has failed. The second attempt, the login has failed. But then the third attempt from our old user, because he reused his username and password, this was a successful login. So this is what credential stuffing is, this process where accounts that are with one website become public knowledge. Those individual users have reused the username and password or email and password. Then an attacker attempts automated logins on a different website and then gets access. This is very common. If anyone here works in information security or really just has been the admin of a website, they've probably run into this. And it's very widely considered to be one of the biggest problems on how people's information is being stolen online. So there was a talk from Usenix Security in 2019 from Alex Stamos. He used to be the CISO at Facebook. I believe he's a Stanford professor now. He very emphatically said that this credential stuffing is the #1 reason that people's information is stolen online, not even close. And he was comparing this with other topics in InfoSec, such as like zero-day exploits or exploiting vulnerabilities, such as that the Java logging vulnerability that was recently in the news. The claim of this talk was that credential stuffing results in even more people's information being stolen compared to those other areas of security work. More recently, it was the Office of the New York State Attorney General here in the United States, they published a business guide for credential stuffing attacks because they determined it was a serious problem for businesses in this area. They monitored an online website and found something like 1.1 million customer accounts were available. All of them were compromised in credential stuffing attacks. And this is just one example. This is a very common problem because if you're just familiar with like password lifecycle things, it's very common for people to just reuse username and passwords. You can imagine that maybe not in your like social circles that are related to computers because people are a little bit more technically inclined, but for the majority of people using the internet, this is a very serious threat to their online accounts and their personal security. So the scope of the work today is not coming up with a solution that will prevent every single request, determining if it's a bot, preventing every single instance of credential stuffing, just because that we don't have time for it today. The scope is much more limited, where we're going to create a victim Phoenix application that has a username and password login. Then we're going to write a script to perform a credential stuffing attack. So you'll be able to get a sense of what this looks like as a defender who has a Phoenix application, and then an attacker who wants to perform a credential stuffing attack. Finally, we're going to use the PlugAttack library on our victim application to block IP addresses that are sending too many login requests, because that's a very obvious sign that the client in that situation is not a legitimate user, that they're attempting to do something malicious. To create the victim application, it's very simple. You just start with the basic Hello World Phoenix project, and then we're going to use this mix task to generate username and password authentication. So after running this and then running your application, everyone's probably familiar with this screen. It's a login form where you can enter an email and a password and attempt to log in. You can also register a new account. So that's our victim application. The other functionality involved is kind of out of scope here. We're really just focused on the login form. Now for part 2, we want to perform a credential stuffing attack. So we're not using real data today. This is just a very simple example of a 10-line username password pair list, where line number 4, the Crow Secret 2022, that's a login, that's like a username password pair that will result in a success. All of the other ones will result in failure, which is similar to what people see in real world attacks. The vast majority of the credentials are not reused, but like an occasional hit rate of something like 1 in 1,000 is viable for an attacker if the data size is big enough, if it's hundreds and thousands of logins and can be automated in an effective way against a website that's not protected. So this is our stolen credentials or leaked credentials. And to do this, we just write a script that does the login requests. I'm not going to go into detail on how to write the actual script because I feel most people in this call can imagine, you have an HTTP client, you're sending a request and then, parsing the response. The code is up on GitHub if you're curious about how to do it and want more detail. So for my example here, it's the env repo, and then you do the mix run do ato credentials10.txt. And you can see login post status 200. That is actually a failed login attempt. The HTTP status code is 200, but it's very common for like real world login systems. A login success and a login and failure may both return 200, and then you have to parse the HTML to determine, if your credential stuffing attempt was successful or failed. But you'll also see here that for the 4th line, the login post status was a 302 redirect, meaning that it was successful. So this is just how it looks, from the Phoenix mix task default implementation. The real world might be different, but the important thing to note is that the attacker is getting a signal that some percentage of these credentials are successful at getting a login. So now that we've kind of covered what credential stuffing is, how it works at a high level, let's define our problem scope for defending our victim application. So when one IP address is sending too many login requests, we want to start rate limiting the IP address or ban it. So for the rate limiting, that means you could do a maximum of 10 login requests in a 60-second period, and then the 11th login request and the 12th would just get dropped. However, after that period, you can just do 10 more. So it's like you could do 10, 1 minute, 10, 1 minute, and you could still do a lot of login requests over some period of time. Then we have our ban example where if an IP address has sent 50 login requests in a 60-second period, that's most likely not someone who forgot their account. That's most likely malicious. So we want to ban it for a week. And these numbers are not really the point. It's more the method of you could do rate limiting and then you could do a ban example, but the actual values would differ depending on what type of software you have. Also out of scope for this example is a distributed deployment of the application. We're just limiting it to one node. So we're going to be using ETS to store a record of how many login attempts are happening, but the distributed database problem, we're just not going to focus on for now. So the reason to use PlugAttack for this problem comes from its documentation, where it states it's a set of macros that can be used to build a plug to protect your web app from bad clients, which is really exactly what we're looking for in this situation. So this is an example rule from the PlugAttack GitHub, where you see throttle by IP address and then your con, and then inside the do block, we have throttle on con.remote IP, which just means, the IP address that is sending incoming request, we're going to throttle based on that IP address over a period of 60 seconds, which is just in milliseconds, a limit of 10. And then we have our storage defined as ETS. A cool feature is that you can actually change your storage with PlugAttack, but we're just going to stick with ETS for now. So installation is very simple. You just add it to your mix file. And then, as we said, we're using ETS. One reason to use that over something like Gen server is when you have many incoming HTTP requests and you have to evaluate, should I allow this request through or should I block on it? With Gen server, you'll get that problem where you have sequential messages coming, to the inbox, whereas ETS has much better support for concurrent operations. The Elixir in Action book goes into really good detail if you're interested in that subject. So now to create our rule to throttle logins, we're going to create a new plug. And then within that plug, we're going to define a rule where we say if con method is post, so it's a post request, like an HTTP post to do the login. And then the path info is user's login. We're going to consider that a login request and then throttle it, period of 60 seconds and a limit of 10. The next step is to add the plug we've just written to our router. So here I defined a pipeline, as you can see, called PlugAttack, but you can do this any way that you think is appropriate for your own needs. And then once that's defined, you'll see in the authentication routes for the orru web scope, I'm doing a pipe through browser, redirect if user is authenticated, and PlugAttack. If you're not very familiar with Phoenix, the thing to really take away from this is that when a con comes in, it gets passed through these different plugs, which you really just think of as a function, and then it's the logic that you've just defined is applied on that. So the con that comes in, if it's a login request, it will match on the rule we just wrote. And now you can test this to see if it works from the perspective of an attacker. So we run the script that we did. The 500 argument at the end of the line, mix run do ATO credentials text. And the 500 is just a rate limit. I had it default to about 1 per second, but 500 is something like 500, I believe it's in a minute. So you can see all of the requests happen in about 1 second. And all of them are 200s except the 302. And then when we run it again a few seconds later, every request has failed and you're getting a 403, which is exactly what you want. So you can see that PlugAttack is a really good tool for this, because with just that little code we've written, we now have our application defended. It's not vulnerable to excessive login attempts, and we can even test it with our script from the perspective of an attacker. So that's part one for this. Yep, you can see the failures there. So now we want to expand our scope a little bit and do multiple rules. So we have one, which is limit login requests from one IP address to 10 per minute, which we just covered. And then for number two, we have if one IP does 50 login requests in a minute, we want to ban it for 7 days or 1 week. And you may be asking, well, what if it gets blocked on the first one? And our response is that a login attempt that is blocked for violating rule 1 should still be counted for rule 2. So this assumes the attacker script is still attempting the logins, even though it's getting blocked, just because you see that in the wild sometimes with attackers. So it's still a good idea to ban them just to cut down on the amount of noise. And then you could also modify these rules for your own convenience. So your first attempt at this may be what I did, where you add an additional rule in your PlugAttack, and you will quickly find that this does not work. It's sort of similar to like pattern matching on a multi-clause function, where if you have some function and it takes like n as an argument, that will always match. And then if you define a function lower in the file where it matches on, let's say, integer 3, the first one will always match. So you're just never going to hit the second one. So when you run into this, you'll quickly figure out the solution is to just create a second plug. So your first plug could be named something like, the Throttle plug. And then your second plug would be the fail to ban plug. If you're curious what fail to ban means, it's named after this software that's mostly associated with Linux, where it scans your log files to find clients that are sending too many requests and then bans them. So it's kind of a reactive approach where the requests have to already happen and then hit your log files. And then you can see in the example we're talking about here, it's a bit more proactive because we're not storing things in log files. It's going into ETS. But back to the topic at hand, we now have 2 plugs, one for each rule that we've defined. And I'm going to use PowerPoint to kind of demonstrate this other little quirk that I ran into when I was configuring this myself. It may be obvious to some viewers already what the problem with this is, but I'll show you a really good example here where our plug 1 is the limiting requests from 1 IP to 10 per minute. So our rule 1 count is now 1. The con keeps going through the plug pipeline, and then it hits plug rule 2, about the 50 login requests in a minute to ban, and now that's counted as 1. Now you can see the next con comes in, it's incremented to 2. So we're going to jump ahead to 10 here. Now that we're on 11, the con is halted on plug 1. So it will never match on rule 2, because when the match happens, like the count is greater than the defined rule, the plug will be halted. So it will never continue in the pipeline and it will stop. So a solution that works specifically for the example we have here is simply reversing the order of the plugs. So now the difference is that plug rule 2 is the 1 IP address doing 50 login requests in a minute. That is a wider rule compared to rule 1, just because 50 is greater than 10. So I'll show you the example here where we do 1, 2, and then 11 and 12. So on this request, you'll see that plug rule 1 is going to halt the request. However, rule 2 is not going to halt it because it's already under that threshold of 50. So this is a example of how you could just do the correct order of the plugs and you'll be successful. But you can also see how if you want a more complex condition, maybe like based on other factors, the fact that halting is so binary, where it just like stops the whole plug, you may require like more metadata or something. So in that situation, putting some information about the request in like the assigns would be a good example. But I don't want to spend all day talking about the different scenarios. I just wanted to give the audience here kind of a good handle on how you could take the first step to preventing excessive login requests. Another really important part that I want to mention is the con.remote IP in your Phoenix app will likely not reflect the real client IP. That's because, on the modern web, if you're hosted on some platform as a service, or just your customer, like your client is going through something, there's like various proxies and things. So the client IP that actually reaches your application probably won't be the real one, but there's a really good library called Remote IP that will traverse that whole problem and get you the correct remote IP. It's also worth noting that our example of banning for 7 days isn't really possible with ETS because most applications get restarted or get redeployed. So it's not really persistent enough. So you may need some other type of data store, or you could end up using a vendor for this. It's just not going to be persistent enough if that 7-day ban is a really hard requirement for you. One other thing I want to mention about PlugAttack, which is a really fantastic library, it supports callbacks that are triggered when a request is allowed or blocked. So you could use that to say, like, write to Postgres and said, okay, on this day we had 5,000 allowed requests and 10,000 blocked requests. And then you can see how you could kind of code that out and do dashboards and things, which is really cool. But again, I was not in scope for this current talk. So my goal with this was to show the audience how credential stuffing attacks work and a method that's very simple to restrict the number of login attempts over some period of time. That's the end of the presentation. Thank you all for coming and listening. I'm very happy to take any of your questions or comments in the chat. So I'll give everyone a minute to go ahead and do that. Thank you.
Can you see me? Because I think you don't, and something is not working for me when it comes to camera. Can you see me, Michael?
I can hear your audio, but
Right.
your video is not loading.
Okay. All right, now. All right. Thank you very much for the presentation. It's really great. I've used this lab once before. Maybe a small question for you. Would you say that it's like something that you should have in every Phoenix app? Would you recommend it to just make it a default thing that should be everywhere?
Yeah, any route in your application that's kind of open to this type of attack, for sure. If you have like a publicly facing Phoenix application that's just meant to, like, let's say, display information, it's probably not as big of a deal. But anything where you're taking like credentials and checking them against a database, you really want some kind of rate limiting. Other examples that I would mention are the creation of new user accounts can happen in an automated way. That's very common for fraud, such as for doing like credit card fraud, making new accounts and trying a lot of purchases. One problem I've seen is if your application has the ability to send email, like let's say you have a project management software and then you invite somebody to a project, you can send an email through that invite where you're saying, invite c@c.com, send it, and now an email has been sent from your company. Spammers really like that and will take advantage of it to send out spam email. So you can kind of get creative and think like any part of your application where there's something sensitive or something computationally or business expensive, it's a good place to apply throttling or rate limiting.
All right, we have a first question.
Okay, so our first question is, can you use it to throttle non-auth requests? So it, in this context being PlugAttack, yes, you can. You can define any condition within your Phoenix app in the rules, and it will throttle on just it's like a pattern match on your con. So it's really flexible and would work great for that example. Okay, so our next question is, what would be the main advantage of this approach overusing load balancer or reverse proxy. More info about the attack since it's integrated with your stack. So this is a very good question. The first thing I would mention is using like a load balancer or a reverse proxy on its own won't really prevent an attack like this. It's very common for like enterprise security software to require that you like spin up a reverse proxy, install their thing on it, and then the traffic goes through it. But it wouldn't really be as tightly integrated with the stack as your next question says. So I've seen examples where they're just trying to match on like the route and the GET request or something, but they wouldn't have the access to detail that you would with PlugAttack, where you can pattern match on the con. That's much more useful. So the main advantages of using PlugAttack, I would say, is if you're doing like platform as a service and you might not even have access to the server, it's very easy to just get the thing implemented in like a day, whereas messing with reverse proxies and load balancers is typically not that fun. It's also independent of your server stack. So if you're moving your application to like a different cloud provider or a different type of web server, it's very straightforward. And the integration with Phoenix really closely is the third example that's kind of portable across. So those are the three things I would say that why I like this approach. This is a very, very good question. Okay, it looks like we have another question. Can it be used to block repeated access to the home page from the same IP? Yes, you absolutely could. So let's say one IP address just sent 1,000 GET requests to your home page in a short period of time. You could define a rule in PlugAttack that says limit the number of requests to the home page one IP address can send in this time period. And if the rule is violated, either just drop the incoming requests, don't serve them, or just block this person from sending me any more traffic. I don't want any requests from them. So that's a very good question.
Right. I think that's probably it.
Nice. That's fantastic. I really enjoyed everyone's questions. They're very good.
Maybe the last one from myself. Someone is writing something, so maybe there will be like the last one from the audience. But do you use it under the hood in your service?
So PlugAttack is open source and it's designed for like kind of consumer applications. It's funny because PlugAttack aims to kind of increase the scope of this, where it would work across a distributed deployment and you could define more complex rules. So internally, we kind of like use Paraxial on our own service and this like recursive thing. But we don't use PlugAttack internally. But the motivation for writing the blog post and doing this is just so that I understood as well as I could how PlugAttack works and the benefits of it, which I think are very good. There are just situations where you would want a bot detection vendor if your needs are just different from an application that would be good with PlugAttack. Both approaches are good. They're just different.
All right. Okay.
I just wanted to thank you for the presentation. Thank you as well. I'm glad you liked the presentation.
That's not a question, that's appreciation. If you want to give more appreciation, then feel free as well. I think that was a great, very informative, great talk, because sometimes we have like 1 hour talk, but we learn just a small bit. I think this is something very useful, something that we can use on a daily basis. And maybe some of you who are listening is gonna integrate this lib tomorrow in the project. So once again, thank you very much. If you want to share something with us at the end, maybe
thank you.
Is there anything that you would like to share with us at the end? Maybe.
Yeah, I had a great time speaking today. It was really good. I appreciate you all coming out to speak with me. If you're interested in Paraxial.io, our website has a sign-up form where you can stay up to date about when the beta launch is coming out and how to sign up for it. or you can get in contact with me on Michael@Praxeal.io. I'm also on the Twitter account if you're curious about this topic, bot detection and Elixir, or you just want to ask me some questions. Looking forward to hearing from you all. Thank you.